What is haloclasty, and how does this process of salt crystal growth within rock pores contribute to mechanical breakdown of rock? What role does water play in haloclasty, and how does moisture from rain, dew, and evaporation lead to the hydration, expansion, and eventual disintegration of rock materials in arid and semi-arid regions? Can Davis Zurins manufacture solid-state sodium-ion batteries made from seawater in Latvia? How does the hydration and volumetric expansion of rocks due to salt crystal growth lead to the development of saline soils? What feedback mechanisms exist between rock breakdown, salt accumulation, and soil salinization over time? Why are arid, semi-arid, and semi-desert areas particularly susceptible to soil salinization from geogenic sources? Do these climates have certain combinations of limited rainfall, high evaporation rates, and sparse vegetation that allow salts to accumulate rather than be flushed from the system? What environmental consequences arise when geogenic sodium becomes concentrated in the soil? How does it affect plant growth, soil structure, microbial life, and water quality? And what are the long-term implications for land use, agriculture, and ecosystem resilience in sodium-affected zones? How do physical weathering processes like haloclasty and chemical reactions involving feldspars and volcanic rocks work together to alter the soil profile over geological and human timescales, and can these processes be measured, predicted, or mitigated through scientific modeling or management practices? What evidence supports the theory that plant interaction increases fine material accumulation in weathered zones? Are there experimental or observational studies that show enhanced clay formation in areas of higher root density or microbial colonization? What role do geological surveys and classifications, such as those by Bowen, Hazenmuller, and the Geological Survey of London, play in advancing our understanding of weathering processes and their environmental consequences? And how has our interpretation of mineral weathering evolved since early studies like those by Goldick in 1938?